Hello, in this lecture we will find the size of 2 times AP, or we will find the value of 2 times AP. Okay, actually you can see in the drawing triangle ABC. It has side AC that equals to 70 units, side BC of the triangle equals to 50 units, and side AB of the triangle equals to 90 units. And we also have a circle. The center of the circle is point P, and point P is actually on side AB of the triangle, and actually side AC is tangent to the circle at point that we will call to this point. See, actually it is the touching point of the tangent with the circle. We'll call that point D. So side AC of the triangle is tangent to the circle at point D, and also side BC is tangent to the circle at point E. That point we will call that point, the touching point will be called E. Okay, again, side BC is tangent to the circle at point E, and side AC is tangent to the circle at point D. Okay, or the touching point of side AC with the circle is D, and the touching point of side BC with the circle is point E. Okay, in the next step we will connect points P and C together by a straight line. Okay, point P and C is connected with a straight line, and also we will connect points D and P with a straight line. As you can see from the drawing, PD is actually the radius of the circle. So I will mark it as R. And we also connect points P and E together by a straight line. And as you can see from the drawing, line PE is the radius of the circle. So I will mark it as R. R is the sign for the radius of the circle. So you can see that actually PE equals to PD, that is the radius equals to R, that is the radius of the circle. Okay, but we have a rule that says that if you have a circle and in outside the circle you have a point, or the point is external to the circle, point V is external to the circle. It is external because point V is not inside the circle and is not on the circle. So point V is external to the circle. So if from point V you draw two tangents to the circle, we'll call the touching point of this tangent with the circle L, and we will do the second tangent to this circle, and we will call the touching point of this tangent to the circle F. So we can say that VF equals to VL. So actually that is a rule that if from external point of a circle you draw two tangents to the circle, then those two tangents equal to each other. So in this circle we draw from external point to the circle two tangents, this tangent and this tangent, and the rule is that those two tangents are equal to each other. So VF equal to VL. Okay, so according to this rule we can say that in the original drawing we have actually a circle, and from external point of the circle, that is to say from point C is external point of this circle, so from point C we drew two tangents, tangent CD and tangent CE. So those two tangents, according to our rule, are equal to each other. So we can write that CD equals to CE because of the rule that if you draw from external point to the circle 2 points, two tangent to the circle, then those two tangents are equal to each other. For that reason, CD equals to CE. Okay? CD equals to CE. Okay? As I already mentioned, also PD equals to PE because both those lines are radiuses of the circle, so they are equal to each other. So we can also write that PD equals to PE equals to the radius of the circle. Okay? And of course, PC equals to itself. We can write that PC equals to PC. Okay? PC equals to PC. So actually we have here triangle CDP. I will paint it in green color. Triangle PDC, and we have also triangle PCE. I will paint it in the black color. So actually those two triangles have three sides that equal to each other. The three sides of this triangle equal to three sides of this triangle. Why? Because this side of the green triangle equals to this side of this triangle, according to our rule that if from external point of the circle you draw two tangents to the circle, then they are equal to each other. So CD equals to CE, and also PD of the green triangle equals to PE of the black triangle, because they both the radius of the circle, so they're equal to each other. And PC of the green triangle equals to PC of the black triangle. Therefore, because we have three sides of the green triangle that equal to three sides of the black triangle, we can deduce from it that those two triangles congruent to each other, or those two triangles overlap each other. Okay? Because three sides of the green triangle equals to three sides of the black triangle. Therefore, the green triangle overlap the black triangle, or the green triangle congruent to the black triangle. Okay, so we can write that triangle okay, we'll write it new page. We can write that triangle, the green triangle CDP overlap the black triangle, it is CEP. Okay, CDP, triangle CDP, the green triangle, overlaps the black triangle, that is CEP, or triangle CDP congruent to triangle CEP. The green triangle congruent to the black triangle. Okay, so we can deduce from it that actually this angle equals to this angle, or angle PCD, this angle equals to angle PCE, this angle. Why? Because of the fact that the green triangle overlaps the black triangle. Therefore, those two triangles are corresponding triangles, and the corresponding triangles in overlap corresponding angles. Those two angles are corresponding angles. So corresponding angles in overlap triangles the green triangle overlap the black triangle, or the green triangle congruent to the black triangle. So in overlap triangles, corresponding angles are equal to each other. Okay, according to the rule that corresponding angles in overlapping triangles are equal to each other, we can say that angle PCD equals, this angle equals to angle PCE. So if we call to angle PCD theta, so if we call to this angle theta, then this angle will be also theta. Okay, so we can say that angle PCD equals to theta equals to angle PCE that also equals to theta. Okay, angle PCD in the green triangle equals to theta, so angle PCE in the black triangle also must be equal to theta, because those two angles are equal to each other. Okay, so I will draw again triangle ABC. So this is triangle ABC. P is the center of the circle and it is on side AB of the triangle, and actually, as you can see from the drawing, PC bisects angle ACB to two equal angles, because angle ACP equals to angle BCP. So CP is angle bisector of angle ACB. Okay? So according to the angle bisector theorem, I write it down. According to angle bisector theorem, the angle bisector, that is to say CP, in the triangle ABC, angle bisector that is CP in a triangle in our specific case we relate to triangle ABC, but it is true for all the triangles that have angle bisector. And as I have already mentioned, CP is the angle bisector of angle ACB because it divides angle ACB to two equal parts, because this angle is theta and this angle is also theta. So angle bisector in a triangle divides the side that it eats as you can see here. The angle bisector of triangle ABC is CP in the red color. It is angle bisector because it divides angle ACB to two equal parts. So this angle bisector CP eats the triangle on side AB, on point P. Okay, this angle bisector in the red color eats side AB on point P, and it actually divides it in a ratio that equals to the ratio of the angles sides. Okay, so the angle bisector CP eats side AB of the triangle. It eats side AB in point P, and actually it divides side AB of the triangle in two parts. And the ratio of those two parts, that is to say AP over BP, equals to the ratio of the angles sides. Angle ACB consists of two sides, side AC and side BC. So the ratio between the sides of ACB angle, that is to say AC over BC, equals to the ratio between AP to BP. Or in other words, we can say that the ratio between AP over PB equals to the ratio between the angles sides, and the ratio between angles ACB sides is AC over CB. Okay? Again, the angle bisector CP in the line in the red color divides the side that it eats. CP eats side AB of the triangle, and it divides it to two parts. And the ratio between those two parts, that is to say AP over BP, equals to the ratio between the angles sides. That is to say AC over BC, or AC over CB, it is the same. Again, the ratio between the parts of AB, AP over BP, equals to the ratio between the angle sides. That is to say AC over CB. Okay? So it is true for every angle bisector in a triangle. The angle bisector in a triangle divides the side that it eats to two parts, and the ratio between those two parts, that is to say AP over PB, equals to the ratio between the sides of the angle that it divides to two parts. And the ratio between the angles the angle sides is AC over BC. Okay, so the ratio that CP divides AB, that is to say AP over PB, equals to the ratio of the angle sides, that is to say AC over BC, or AC over CB, it is the same. Okay? So the angle bisector CP in the red color divides the side that it hits to two parts, and the ratio between those two parts, AP over PB, equals to the ratio between the angle's sides. That is to say AC over BC. Okay, or AC over CB is the same. Okay, and it is true in every triangle that you have angle bisector. In this triangle, the angle bisector is CP in the line in the red color, and it is angle bisector because it divides angle ACB to two equal parts. This angle equals to this angle. Okay? So this angle bisector divides the side in the triangle that it hits, that is to say AB. AB is divided by CP to two parts, and the ratio between those two parts, that is to say AP over PB, equals to the ratio between the angle's sides, that is to say AC over CB. Okay? So we can define that AP equals to X and you should remember that we have already in the question the sides of triangle ABC are given. Side AC equals to 70 units, side CB or BC equals to 50 units, and the side AB equals to 90 units. Okay, side AB equals to 90 units, so actually PB equals to AB minus AP. So it will be equal to 90 minus X. Okay, because it is AB that is 90 minus AP that is X. So 90 minus X equals to PB. Okay, so actually I'll write again the equation. I will mark it as equation 1. AP over PB equals to AC over CB. So, as I've already mentioned, we defined that AP equals to X and PB equals to 90 minus X. Okay? We defined that AP equals to X. You can see here AP equals to X and PB equals to 90 minus X. Okay? So AP equals to x, PB equals to 90 minus x. So in the question 1 we can substitute AP by x and PB by 90 minus x, okay, because they are equal to each other. Okay, we do it now. Instead of AP, I write x over PB, and PB equals to 90 minus x. So we'll substitute PB by 90 minus x. All equals to AC over CB. Okay. Again, I substituted AP by x and PB by 90 minus x. But we have already know that AC equals to 70 and CB equals to 50 units. So we can substitute AC and CB. I write it here. We know that AC equals to 70 units and CB equals to 50 units. So, okay, AC equals to 70 units and CB equals to 50 units. It is given us in the question. So I will substitute AC by 70 units and CB by 50 units. Okay, so we'll get that x over 90 minus x equals to 70 over 50. Okay, I substituted AC by 70 and CB by 50 because they are equal to each other. Now we know that 70 equals to 7 times 10 and 50 equals to 5 times 10. Okay, 70 equals to 7 times 10 and 50 equals to 5 times 10. So here we can also substitute 70 by 7 times 10, and we can substitute also 50 by 5 times 10. Okay, we substituted 70 by 7 times 10 and 50 by 5 times 10. So as you can see in this equation, we can cancel 10. We have 10 in the numerator and we have also 10 in the denominator, so we can cancel them, or we can reduce the 10 from the numerator and from the denominator. Okay, so we get that x over 90 minus x equals to 7 over 5. Okay, we cancelled 10 in the numerator, and also we cancelled 10 in the denominator. We cancelled 10 in the denominator. Okay, here we can multiply by 5 both sides of the equation. We'll get that 5 times x over 90 minus 6 equals to 7. Okay, here we multiply both sides of the equation by 5, so 5 divided by 5 times 5, 7 divided by 5 times 5 equals to 7, and x over 90 minus 6 times 5 equals to 5x over 90 minus 6. Now we will multiply both sides of the equation by 90 minus 6. Actually, we can multiply both sides of the equation by 90 minus 6 because, as you can see here, x equals to AP. X equals to AP, so and AB equals to 90. So AP, that is x, is less than 90. So 90 minus 6 must be a positive number because x is less than 90. So 90 minus 6 is a positive number. It can never be 0, so we can multiply both sides of the equation by 90 minus 6. Okay? So then we will get that 5x divided by 90 minus 6 times 90 minus 6 equals to 5x, and 7 times 90 minus 6 equals to 7 times 90 minus 6. Okay? We multiply both sides of the equation by 90 minus 6, so 5x divided by 90 minus 6 times 90 minus 6 equals to 5x, and 7 times 90 minus 6 equals to 7 times 90 minus 6. Now we will open the brackets. We'll get that 5x equals to 7 times 90 is 630, and 7 times minus 6 equals to minus 7x. Okay, we opened here the brackets. 7 times 90 is 630, and 7 times minus 6 equals to minus 7x. Now we will add 7x to both sides of the equation. We'll get that 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. Okay, here we added 7x to both sides of the equation, so 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. Now we will divide both sides of the equation by 6. And we will get that 2x equals to 105. Okay, we divided both sides of the equation by 6, and 12x divided by 6 is 2x, and 630 divided by 6 equals to 105. So, but we know that x equals to AP. Yes? X equals to AP. We defined x as AP. So x equals to AP. So 2 times 6 equals to 2 times AP, and actually 2 times 6 equals also to 105. So you can write in the second equation that 2 times x equals to 105. Yes, this is the first equation, but we know also that 2 times x equals to 2AP, so we will add that 2 times x also equals to 2 times AP. Okay, here we know that 2 times x equals to 105, so we wrote that 2 times 6 equals to 105, but we know also that 2 times x equals to 2AP, so we can add here that 2 times x equals to 2 times AP from here. So we can deduce from this equation that 2 times AP equals to 105. Two times AP equals to 105 units. Okay, so this is actually our final answer to the question, that the value of 2 times x is 105 units. Okay, that is the answer to the question, that the value of 2 times AP equals to 105 units. Or you can see from the drawing, the value of 2 times AP equals to 105 units. Okay, so now I will summarize the lecture. Actually, we wanted to find the value of 2 times AP, and we have a triangle ABC with AC that equals to 70, BC, side BC equals to 50 units, and side AB of the triangle ABC equals to 90 units. And we have also a circle that actually side AC of the triangle is tangent to the circle in point B, and side PC of the triangle is tangent to the circle at point E. And actually we have the rule that if you have from external point of the circle you draw two tangents to the circle, then those two tangents are equal to each other. So CD equals to CE, and also PD equals to PE, because both are radiuses of the circle, so they equal to each other, so PD equals to PE, and also PC equals to itself, PC equals to PC. For that reason, the green triangle is congruent to the black triangle, or the green triangle overlap the black triangle. And we can deduce from the fact that the green triangle congruent to the black triangle that angle TCP in the green triangle equals to angle PCE in the black triangle, according to the rule that corresponding angles in overlapped triangles are equal to each other. So actually we drew triangle ABC again with those two angles that are equal to each other. So we have a line PC that is angle bisector. Actually it divides angle ACB to two equal parts, and according to angle bisector theorem, the angle bisector PC in the red color divides the side that it eats, that is to say CP eats side AB of the triangle, to two parts, AP and BP, and the ratio between those two parts, that is to say AP over BP, equals to the ratio between the angle sides, that is to say AC over BC. So or AP over BP equals to AC over BC according to angle bisector theorem. So we can define that AP equals to X, so BP will be equal to 90 minus X. We have here actually one equation with one variable that is X, so we can easily find the value of X, and we found that 2X equals to 105 units, and actually X equals to AP. X equals to AP. As you can see, we defined that AP equals to X, so 2 times AP equals to 2X, and we found out that 2X equals to 105 units. So 2X equals to 2 times AP, and 2 times AP equals to 105 units. Okay? We found out that 2 times AP equals to 105 units, and that is exactly what we wanted to know from the beginning of the question. We wanted to know the size of 2 times AP, and we found out that the size of 2 times AP is equal to 105 units. Okay, thank you very much.